Hello guys, so welcome back to our lab sessions for this course. And today we're gonna discuss lab 5. So in lab 4 we discussed diode clipping circuits in which we have what we can call individual clipping. I mean you have either positive or negative clipping. Now we're gonna in this lab explore more interesting circuits in which we're gonna make explore two circuits that can make dual clipping. Okay, I mean clipping in the positive and the clipping in the negative. Okay, so let's start by the first one. So the first clipping circuits are really very simple. It is just a combination or integration of the two previous circuits that we explored in lab 4, in which you have either this configuration or this configuration. Now you have both. Okay, so we're gonna have a clipping in the positive half cycle at 3.3 plus 0.7, which is 4, and another clipping in the negative half cycle at minus 3.3 minus 0.7, which is minus 4. Okay, so let's open my project here for that lab. So experiment 1, yes, yes. So we have here two batteries. Okay, let's zoom out because it's not clear for us. Still not good. So we want this circuit to explore the whole screen here. So use this option, this option here. It's called zoom area. And you just, zoom the area that you want. Okay, that's very nice now. So this is just, the implementation of that circuit. Again, VM is 14 VRMS. If you convert VRMS to maximum, 14 multiplied by square root of 2 will give you around 20. So we expecting now to have a sine wave with 20 positive and minus 20 in the negative half cycle. Okay, and here is our two diodes, silicon diodes with VBI equal to around 0.7, and our two batteries. Well, let's run this. So and reverse that guy, and we should apply this. It's already applied. Okay, and as you see guys here, this is the input. If we're gonna measure its maximum and negative, so we can right click on the marker here and go to next Y max. So it goes to the Y max. It's 19.744, which is, as I said, around 20. And we can also move this to the negative. It should be, of course, the same, but negative. So minus 19.729. Okay, so the peak to peak is around 39.4. This is for the input. Let's now explore the output. Okay, so let's see what's required. So the output here is the voltage between that point and that point, which is basically VB. So we want the VB. So for VB, we set VA to 0. Let's reverse this, and we set VB for to DC. Okay, this is the one here. Okay, and here is VB, guys. So VB, as you see, guys, there is clipping from both positive and the negative. Okay, so let's measure the positive. So it's now not for the, so select trace B, and let's go to max. Okay, the max is 3.984, which is around 4, as we said. It's our theoretical value. So let's check the min, which would be the clipping. It is minus 3.984. This is marker 1. So the first one. Marker 2 is the second one here. Okay. So we have here a clipping at exactly the same point, but with just change in the sign. And of course, if you control the batteries here, I mean the voltage of the batteries, you're gonna have different levels. But we're gonna do that with another simpler way, which is experiment 2. Okay, so that's basically what's required in experiment 1. Of course, you should answer these questions in the which is just what we did right now. Very easy. Okay, now let's and of course, if you add them together, let's add them together. So let's check VA first. So this is 0. And this is VA. Look, guys, VA is not, it's not sine wave. Okay, if we open on a side here the input, there are differences. Look. So, and we explained this in the lecture. If you explore the lecture in which I am, analyzing this circuit, you will understand why we have such a shape. So, of course, you will show, you must see or watch the lecture before doing that lab to understand what's happening exactly. Okay, but again, if we add VA to VB, we should get this. So let's go back to oscilloscope 1 here and set it to add. Okay, of course, it will not change from the first time, so you should do that none, then go again to sync. Yes, and DB should be DC as well. Then go to single, and look, guys. Now this is exactly this one because this is Kirchhoff. So VO from that point to that point plus VR is exactly V input. Okay, and of course you can check as required here by the voltage peak to peak of that one and the voltage peak to peak of that one. We can check it now. So let's here go to the max. Look, guys, 19.7, just like here. If we go to the max here, 19.7. If we go to the min, minus 19.7. If we go to the min here, minus 19.7. Okay, that's basically the effect of Kirchhoff. Now let's explore the second experiment, which is more interesting actually. So in the second experiment, we have a circuit that will do the clipping, the dual clipping in positive and negative, but with just one power supply and a potentiometer. So it is our first time to see the potentiometer, and I will teach you how to add it to your circuit. So let's open this. Let's open this circuit, lab 5, experiment 2, 1 battery circuit. Okay, again, let's zoom out. It's still ugly, so we take this, it's called the zoom area, and just highlight over our design. It will fill the whole area, which is really nice. Okay, here are two nodes to measure the voltage of that point, the voltage of that point, and here is the potentiometer. How to integrate the potentiometer? It's really easy. From place, component, okay, and I just write it here. So you have here a group called I think regular or something. So let's see. Let's check here the manual. So yeah, basics. So let's open a group called this group basics. Okay, and if you just type B, here is the potentiometer. Okay, and this is basically what I have done here. Okay, guys. So and you can control its level. So the potentiometer, of course, is a variable resistor. So by changing this arrow here, we can change the value. I mean, this portion and the left portion of the potentiometer and the right portion of the potentiometer, and we change it just hover over the symbol. This will appear for you. Then you can change it, and it's changing with 5% increments. So we're gonna make it first at 50%. I mean, the right portion of the potentiometer or the resistance equal exactly to the left portion of the potentiometer. The idea of this circuit is that this potentiometer with a ground, in the middle here, will create a negative voltage here and a positive voltage here. Just like, or just exactly, we can say what we have for this circuit. So for this circuit, the voltage at that point, at the end side of that diode D1, is positive 3.3. Here V2 will be positive 3.3 if this is 50%. And here the voltage of the B side of D2 is minus 3.3. If we measure right now using this probe, we will find that the voltage at that point is minus 3.3. And we can insert the probes from here. Okay, just to remind you. Good. So let's try. And here the battery is doubled these two together, so it is 6.6. So when this potentiometer is 50%, you will have here 3.3 and here is minus 3.3. So you will have exactly the same output as here. One last observation or a condition for this circuit to work flawlessly for you, okay, is that the total resistance of RB, which is 1 ohm here, should be must much less than R. Here R is 1 kilo, this is 1 ohm, just 1 to 1000. Otherwise, you will have very strange outputs. Of course, it's not strange if you understand it, and I'm explaining that. So in that video, this link will lead you to the video in which in that video, in that link, I'm explaining, in my other videos, how this circuit work, assuming that RB is really much less than R. And in another video, I'm explaining why we have such condition. And I'm showing you with some, if we violate this condition, then we will have, strange outputs, we can say. Okay, so let's go back to our circuit here. So we construct it as required here. We make it 50% in the beginning. We did that, it's 50% as you see here. Let's now run it and check our output. Before we check our output, just look at the V2, the voltage of that node, and the voltage of that node. So V2 here is 3.3. And V1 here is minus 3.3, just like what we want. Okay? We want this point to have a positive voltage of, constant positive voltage of 3.3, and this one a constant negative voltage of 3.3. And that's what we have right now, using not two sources, not two batteries, not two power supplies, but just one power supply and a potentiometer. Okay, so let's check the input. Of course, the input doesn't change, it's still the same. You have 19.7 as max, minus 19.7 as min. And let's check now the outputs. So let's check first, this is VB, this is V out, the voltage from, from the ground here until this point, which is on B. And look, guys, here we have a clipping. Let's check the values of this clipping. So we select a trace, channel B, and go to max. So the max is 3.98, just like what we get from the first one. Let's move this to the min. This is marker 1. Minus 3.98, just exactly what we get with the first experiment. Okay, but with just one power supply. One power supply. Okay, good. Let's check now voltage A or I'm sorry, VR. This resistor voltage. So we put this on 0 and put this on DC. And look, guys, it's also exactly what we get from the first one. And remember, this is different from this. This is the input. Look at this distortion here. So we have here a flawlessly sine wave, but this is not a complete sine wave. This part only the sine wave, and this part only the sine, but in between there is a 0. And again, I'm explaining in my videos of the lectures, why we have zeros there. Okay, now one final thing again is we add them together, and we should get the same as the input. So I usually, again, it doesn't show from the first time, so we push none here in a single again, and here it is. Here it is. This is exactly like this. Of course, we just changed the time scale, so make it 5. As you see, guys, they are now exactly the same. Okay. Now let's play this game in which we change the potentiometer, value, and see the change in the clipping voltage or the clipping level. Okay, so let's close the input right now and go back to channel B. Again, it doesn't show from, because this is not YT. Now it's YT. Okay, this is with 50%, 50%. We can decrease more so we can see better. Yeah. So good. Oh, let it 5. Okay, 5 is good. This is with 50%, 50%. Now online, we're gonna see that a change in the value here will change this clipping. If we bring it to 100%, okay, so let's get to the 100%, which means one side is 0 and the other side is 100% of the value. Okay, of course, again, it doesn't refresh by itself, so we need to do this trick, none and single. Look, guys, so the clipping in the negative side become bigger than the clipping in the positive side. Okay, so the clipping at the negative side, let's measure it. It will be minus 6.6 minus 0.7. So let's check that. So let's move that to the select a trace first and make it B, and move this cursor to the minimum. Oh, I'm sorry. Yeah, it is 1. That's fine. So 1 now is at the minimum, and it is minus 7 point around 3. And remember, minus 6.6 minus 0.7 will give you minus 7.3. Okay, because now when we set it to 100%, that means that this cursor is on the far left portion here or side of this potentiometer. So V2 is connected to the ground. So it's like we decrease the VB1 by 0 to 0. So the clipping will happen at VB1 plus 0.7 in the positive half cycle. The clipping will happen at VB1 plus 0.7. VB1 is now 0, so it will be only 0.7. This is basically 0.7. So let's check that. So we mark marker 2, go to max. It's around 0.7, 690 millivolt, which is really 0.7. Okay, and now the total resistance is at V1. So the total resistance will take the whole voltage 6.6. So this point will be minus 6.6. Look, guys, 6.6. And this point V1, if we check it, it's almost 0. It is in nanovolt. Nanovolt is just 0. Okay, so we have a clipping at 0.7 here and a clipping at minus 7.3 here. Let's do the opposite. Let's do it. Let's make this 0. Okay, again, it doesn't refresh, so we make this trick none and single, and again, here it is. Now look at the clipping in the positive. So now this situation, which is 0%, means that the cursor here moves to the far right. So V1 now, or which is corresponding to VB2, is connected to the ground. So this is like if we decrease VB2 to 0. So the clipping of the negative half cycle will happen at minus VB2 minus 0.7, minus 0 minus 0.7. It's just minus 0.7. So cursor marker 1 is at minus 690, which is minus 0.7. And marker 2 is at the max here, which is the positive clipping, which is 7.3, which is 6.6 plus 0.7. Again, when the marker or the cursor comes at the far right, all the resistance will be to the left here. So V2, which is corresponding to VB1, will take the whole 6.6 of E. Of course, I'm explaining this circuit and how it works in that video, so you should watch it. Okay, so that's basically the dual clipping of the diode with 2 circuits, a circuit with 2 sources like this one. Okay, it's really simple to understand, but it needs 2 sources. The second one a little bit tricky. Okay, but the trick is really simple, which is just replacing the 2 batteries with battery with double of the voltage or the values and a potentiometer. Okay, so that's all, guys, for this lab. Thank you very much for watching, and see you in the next lab.